Hi, my name is Alusine Barrie and welcome to this session on number basis. So actually number basis is one of those topics in maths that actually scare students away. It's not difficult, but it's just sometimes the way it's introduced, and because of its abstract nature, often students are scared for maths in general when they encounter number basis. We'll be going through number basis, and quickly let me set my timer for 15 minutes, and then once it goes, they will try and wrap up as soon as possible. Move on to the problem solving. Okay, so for starters, number basis really just represent the number of digits or the combination of digits that a counting system uses to represent numbers. Okay, so the counting system that we use widely across human populations is base 10, which is also called the decimal base system. And really, this is as a result of the fact that humans have 10 fingers. Okay? Across human populations, even when there's no sort of interaction, humans use base 10 counting system. So this includes the digits 0 through 9. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fingers. Okay? When we finish counting with our 10 fingers, we have to begin all over again. Okay? Alright. So what happens with base 10? Let me just give you an example of a number. The number, let me say 3,614. Each digit in this number has a value that depends on its place. For example, although 6 may look like a bigger number, but 3 has a value that's higher than 6. Okay? In this particular number, 6 is in the hundreds place. So the true value of 6 here is when we multiply it by 100, because there are 6 hundreds in this particular number. And there are 3 thousands in this number. Here we have ones, like 4 ones, 4 units, and then we have 110. So we have 4 units, 110, 600, and then 3 thousands. If we put all of these together, so this will really be just, let's begin from the largest digit. We say 3 multiplied by 1,000, 6 multiplied by 100, 1 multiplied by 10, and then 4 multiplied by, this is actually just 1. Okay? And the reason why we're going to use something, one of the properties of exponents, which is 10 raised to the power 0, which is just really 1. So this is just representing 1s. Okay? So therefore you often see this, especially let's just focus on these factors of 10. So you have 1 multiplied by 10 is 10, 10 multiplied by 10 is 100, 100 multiplied by 10 is 1,000. So each time we're moving a place, we are counting in bundles of 10. We're increasing in bundles of 10. Okay? So that's what we do for base 10. Now, fun fact, Babylonians, long time ago before even the birth of Jesus, they used base 60. So they were counting in bundles of 60. Now, generally we count in bundles of 10. However, computers, they count in bundles of 2. And this is based on the fact that computers use tiny, like minuscule machines that only recognize on/off. So it's easy to represent them with zeros and ones. Okay? So, for example, when you click on your keyboard the letter A, inside your computer's memory, it's really recorded as 0, 1, 0, 0, 0, 0, 0, 1. This is how it's represented. Your computer recognizes that clicking as this number in zeros and ones. Okay? So computers use this number-based system that uses bundles of 2 for counting, for representing numbers, is called the binary or base 2 counting system. Okay, so it uses 2 digits. For base 10, it uses 10 digits, and these digits are 0, 1, 2, all the way to 9. And then for base 2, it uses 0 and 1. So it uses 2 digits, so it's called a base 2 counting system. Another number base system that's also commonly used in computers is the hexadecimal system, which is base 16, right? So, yeah, so it's slightly different, but you can see why it's easy for that to work, because you can represent 16 as a factor of 2. So computers can be able to compress it down to 2, right? Just 2 raised to the power 4 is 16. So anyway, that's enough for computers. Let's look at some examples. Anyway, also remember, we use dozens as a way of counting, right? We use dozens, so that's the duodecimal system, base 12. We also use it for time, clocks, and things like that. So we don't just use base 10, we commonly also use this duodecimal system. For our computers, we use a binary system. Okay, so let's solve some examples. Let's first of all start with converting a number. So we can convert numbers from one base to the other. Let's start by converting a number that is in base 6, right? So this will have the digits 0, 1, 2, 3, 4, and 5. Okay? Remember, it's one less the base, the highest digit. So we have here convert the number 4, 1, 0, 0, 0, 1 in base 6 to base 10. To base 10. To a number in base 10. Right? How it will be represented if we are counting in base 10. So what often happens, the method here is to continuously expand into factors. Okay, we will expand this number out into factors that are whose exponents are based on the place's value of that particular digit. So for example, for this number, we'll have 4, 1, 0, 0, 0, 1. Let me see if that's it. No, it's actually just 2 zeros. Okay? Yeah, let's go with 2 of those. 6. So this would be equal to, to convert this in base 10, we'll start with the first number. We say 4, we multiply that by the base. When we were in base 10 earlier, when we were expanding those numbers, we were multiplying by factors of 10, right? In this case, it's base 6, so we are multiplying by 6, but then we are raising it to the relevant power. Remember, just as earlier, I told you, any number that's raised to the power 0 is 1. So even the units in the base 10 we are doing, we could represent 10 as 1 in the units column. So therefore, the first digit always represents let me use another column, 0 as the power. And then 1, 2, 3, 4. So it starts from 0 and then the powers increase as we go along. Similar for what you have for 10 raised to the power 0 is 1, that's the units, and when 100 is really 10, so and then we have 10 which is just 10 raised to the power 1, 100 is 10 raised to the power 2, 1000 is 10 raised to the power 3. Okay, so that's something similar we're doing here. Yeah. So that's 6, but then raised to the power 4. So we have 2, 4, 5 digits. So often you have one less at the beginning. So we start from there. And we're using red. Okay, plus the next number is 1 multiplied by the base 6, and then we raise it to the second power from the left, so that's 3. Close that again, plus we say 0 multiplied by 6, which is the base, and then raised to the power 2. We close that again, we take the next one, the next 0, so we say 0 multiplied by 6 raised to the power 1. Right? See, we are scaling down as we go along. And then 1 multiplied by 6 raised to the relevant power 0. Now this is the expansion. Okay? If you have negative numbers, okay, we actually have that sort of example here, so we'll get to it when we talk about that. That will go into negative powers. Okay, so what we'll do now, so we'll just have, just for the sake of time, so we have 4 times 6 raised to the power 4. 6 raised to the power 4 is 1,296. 1,296 plus 1 times 6 raised to the power 3. 6 raised to the power 3 is 216 plus 6 raised to the power 2, 0 multiplied by 6 raised to the power 2 is 36 plus we have 0 multiplied by 6 raised to the power 1 is just 6 plus 1 times 6 raised to the power 0. Remember, it's always 1. Any number raised to the power 0 is 1. Now, since we've already talked about, actually, let me bring this whiteboard closer. Let me see if you guys can see clearly. Almost. Anyway, I'll take it in and out. So what we have now here, we have 4 multiplied by 1,296, which gives us, so it will be equal to, from the step there, 5,184 plus, we take the next number 1 times 216, it's just 216 plus 0 times 36, any number multiplied by 0 is 0. So that's 0 plus 0 times 6 again is just 0, and then we add finally 1 multiplied by 1 is just 1. Okay? Just so you see, we move from this step here. Okay. So now, let's add these numbers together. So this will be equal to 5,184 5,184 plus 216 plus 1 is 5,401. So the answer, the number 41001 in the 6 is equal to the number, this number here, 5,401 in base 10. So that's how you convert a number from another base to base 10. Now, the method we would use to convert a number from base 10 to another base would be the reverse. Instead of multiplying out, expanding out, we'll be dividing two by that particular base. Let's look at an example. It says here, let me see if this is the right one. Okay, so this example 0 says convert 321 in base 10, the base is often written at the bottom, to a number in base 8. Right? If we are using base 8. Now, how you do this, you basically draw a line. I mean, this should be shortcut really. You write the number you are going to try to convert, 321, and then you'll be dividing 2 by 8. The key thing here is each time you are keeping the remainder. That remainder is what we'll be using to put the, that's 15 minutes gone. Let's try another 15 minutes and see how far we can go. Let me see if it's actually keeping up. Alright, we have about 5 minutes of recording time. Okay, let's do this quickly. So we put the base we are trying to convert to here, and then we'll be dividing 2. So how many times does 8 go into 321? Well, realizing the fact of place values, let's take it step by step. So how many times does 8 go into 32? It's 4 times, right? Remember, 0. So this will almost be like 40 times in reality, because we are taking all these first 2 place values. Now, so that's 4 times, remember, 0. How many times does 8 go into 1? Really, we cannot. So basically, it's going to be, it's going to be 40, remainder 1. Goes there 40 times, remainder 1. So now, how many times does 8 go into 40? It goes there 5 times, remainder 0, because 8 times 5 gives you 40. Next, we will continuously divide 2 by 8. 8 into 5 is 0 times. Then we put down our remainder 5 again. So now, once we reach this step where it's 0, then we just stop and just carry this number. So and then how you find the answer is by reading from the bottom up. So therefore, 3, 2, 1 in base 10 is equal to 5, we read from the bottom, 0, 1 in base 8. That's our answer. Okay? So this is how you convert from any base to base 10, and then from base 10 to any other base. You do the same thing for any other base. Just divide, if it's base 7, divide by 7. If it's base 4, you divide by 4. Alright. Well, see you in the next video where we'll solve other problems.